called valency. Combining capacity is called valence. Combining capacity is called valence. So from these examples, we can draw a conclusion regarding the valence. So there will be 1 electron in hydrogen atom, 2 in helium, 3 in lithium, 4 in beryllium, 5 in boron, 6 in carbon, 7 in nitrogen, and 8 in oxygen. So we have to find the valency of these all elements. So first of all, we have to consider hydrogen. Hydrogen. So for hydrogen, there is only 1 electron. That means the center is nucleus. There is only 1 electron. So we can fill that 1 electron in the outermost shell. In the case of hydrogen and helium, we need 2 electrons to complete outermost shell, right? Because the outermost shell, the equation is 2 into 1 square. Therefore, a maximum number of 2 can be accommodated in the outermost shell. So here 1 electron is less in the outermost shell. So the valency of hydrogen is, this is hydrogen. The valency of hydrogen is equal to 1, because 1 is needed to complete the outermost shell. So what about the helium atoms? What about the helium element? Helium, there will be 2 electrons. So nucleus here is the first shell. The first shell can fill a maximum of 2. So helium consists of 2. So the outermost shell is completely filled. Therefore, the helium atom consists of, for the helium atom, the valency is 2. What about lithium? For lithium, center is nucleus. There will be 3 electrons. The first shell can accommodate 2. The next one can accommodate 1. So the outermost shell consists of only 1 electron. Here in the case of lithium, the combining effect is called, the combining capacity is called valency. Therefore, the outermost shell consists of only 1 electron. So here the valency is 1. What about beryllium? Beryllium consists of 4 electrons. So the first one, nucleus, there will be 2 shells are required. The first one 2, the second one 2. The outermost shell consists of 2 electrons. Therefore, the valency is equal to 2. What about beryllium, lithium, beryllium? So here carbon, we use carbon. Carbon consists of 6 electrons. So nucleus, first shell 2, second shell 1, 2, 3, 4. Arrangement is completed. 1, 2, 3, 4. So the valency is equal to 4. But in the case of nitrogen, we want to discuss the case of nitrogen. So what about nitrogen? Nitrogen consists of 7 electrons. So first orbit there will be 2 electron. Second orbit there will be 5 electron. Actually, all the students will write the valency is 5. 1, 2, 3, 4, 5. But that is actually wrong. The combining capacity is called the valency. That means here the valency is 3. Why? To complete the octet, there is 3 electron is needed. So it is much easy to accept 3 electrons rather than dropping these 5 electrons. So it is easy to achieve or easy to accept 3 electrons to complete the octet. So 8 is the outermost maximum number of electrons can be accommodated in the outermost shell, and 8 is required to complete the octet, and here there will be 5 electrons. So it is easy to achieve or it is easy to accept 3 electrons to complete the octet. Therefore, the valency is 3. Why in the case of beryllium, it is beryllium 2 plus 2, that is first orbit there will be 2 electrons, second orbit there is also 2 electrons. So it is easy to drop that 2 electrons. It is easy to drop that 2 electrons rather than accept 6 electrons. That's why the valency is 2. In the case of nitrogen, it is easy to accept 3 electrons rather than dropping this 5 electrons. So here the valence is 3. What about oxygen? Oxygen, first one 2, second one 1, 2, 3, 4, 5, 6. So actually the valency is, there will be 6 electrons are in the outermost shell. If actually they accept 2 electrons, then the octet is complete, then the valency is 2. So to obtain the stability of the atoms, they need to accept 2 electrons. So this is the concept of valence. This is the concept of valence. Now in the case of lithium, for in the case of lithium, 2 plus 1. First orbit there is 2, second orbit there is 1. So 7 extra electrons are required to complete the octet. So the valency is 1. It is easy to drop that 1 electron in the outermost shell to maintain the stability rather than accepting the 7 electron. It is difficult to accept the 7 electron, but it is easy to drop that 1 electron. Therefore, the valency is 1. So in the case of beryllium, it is 2 plus 2. First orbit 2, next orbit 2. It is easy to drop that 2 electrons rather than accepting the 6 electrons. In the case of boron, there will be 5 electrons. That means 2 plus 3. So the valency is 3 because it is easy to drop that 3 electrons rather than accepting 5 electrons. Then carbon is 2 plus 4. The valency is 4 because if it is drop that electrons, it is 4. If it is accept that electrons, it is also 4. So the valence is 4. What about nitrogen? Nitrogen, the electronic configuration is 2, 5. That is first shell 2, next shell 5. That means it is easy to accept another 3 electron to complete the octet rather than dropping that 5 electrons. So that's why the valence is 3. Here the valency of oxygen is 2. That's why the concept of valency. That is the concept of valence. So next one, there will be 3 topics are pending. Sorry, 4 topics are pending: atomic number, mass number, isobar and isotope. Isotope and isobar. So first, atomic number and mass number. Atomic number and mass. So here is an element called X. There is A, here is Z. Here X, A, Z, where A is called atomic number and Z is called mass number. What is atomic number? Total number of electrons or protons in the element is called atomic number. So the total number of electrons or protons inside the element is called its atomic number. What is mass number? The sum total of proton and neutron in the element is called mass number, which is denoted by A. This is denoted by Z. So atomic number is denoted by Z and mass number is denoted by A. So A is not atomic number, A is mass number. Actually it is wrong. A is mass number, A is mass number, A is mass number and Z is atomic number. Z is atomic number. So the total number of electrons or protons in the element is called atomic number Z, and the sum total of proton and neutron in the element is called mass number. Actually in the first stage it will write A as atomic number and Z as mass number. It is totally wrong. Actually, I am wrong in that case. A is mass number and Z is atomic number. It's an accidental error. Sorry for that mistake. So A is mass number and Z is atomic number. So for the simplification, it is just write A not equal to A. That means A indicates not the atomic number. A not equal to A means A not indicates the atomic number. A not equal to A means A not indicate the atomic number. A is the mass number. Z is the atomic number. So the total number of electrons or protons in the element is called atomic number. And the sum total of protons and neutrons in the element is called mass number, which is denoted by XAZ, where A is the mass number and Z is the atomic number. Clear? So this is the general case. Then we want to know about, so what about A minus Z? A minus Z is which gives total number of neutrons. Total number of neutrons. That is mass number minus atomic number will give the number of neutrons in the element. Mass number minus atomic number will give the number of neutrons in the element. So the next one is isotope. Isotope. Isotope means atoms of the same element having same atomic number but different mass number. Atoms of the same element having same atomic number but different mass number are called isotopes. For example, hydrogen have three isotopes called protium. First one is protium, 1H1. Second one is 1H2. Here the atomic number is same, the mass number changes. Deuterium. And the third one is tritium. So here the atomic numbers are same. Atoms of the same element, hydrogen, having same mass number, same atomic number, 1, 1, 1, different mass number, 1, 2, 3. That is called isotope. So what about isotope? Atoms of the same element having same atomic number but a different mass number is called isotope. So we want to check about isobar also. Isobar. Atoms of different element having same mass number but different atomic number. Having same mass number but different atomic number is called isobar. Atoms of a different element having same mass number but a different atomic number is called isobar. Atoms of the same element having same atomic number but a different mass number is called isotope, and this is isobar. Atoms of different element having same mass number but a different atomic number is called isobar. These are the topics in the chapter atomic structure. So what all the things we are studied in this chapter? The first one we studied about the structure of the atom. Second one, Thomson atom model. Third one, Thomson atom model means Thomson atom model concept, then their limitation, then Rutherford atom model. What all the things are there in Rutherford atom model? alpha parting scattering experiment is there, their observation, their conclusion, their Rutherford atom model is there, then their limitation. Then fourth one is Bohr atom model. There will be 3 postulates regarding Bohr atom model. Then electronic configuration. Electron configuration. Then valency. Finally, atomic number, mass number, isotope, and iso. These are the things we studied in the chapter. So, thanks for joining this class, and I am Sudhi signing off here. See you in the next class with the another topic.